All right, welcome everyone. We wanted to do this interactive Ask Me Anything session. We get a lot of requests from the internet from clients, and they want to understand kind of some of the latest trends and stuff we're seeing um, with our testing. We have the privilege to see behind the scenes on a lot of applications, different industries and such. So, in sharing that and giving back to the community and helping you out with your organization, I wanted to kind of give you an insight into some of that and what we've got going on here. So, with that, we have Geoff Walton. He is the practice lead for the application security team. We also have Rob Simon, which, Rob, we're at the beach. Are you going to join us? Oh, there you are. Uh, Rob's on mute, it looks like, and he is the practice lead for our mobile and IoT hardware security team.
I am now off of mute.
All right. Well, good to have you folks. If you didn't see the description for the Ask Me Anything, a couple of topics we're going to take a look into is kind of the trends we've been seeing, some of the nuances of things we've seen where we bypass protections and such with software and things like that. And we'll also take a look at IoT, some of the projects you've worked on there, what types of things you've observed, and other kind of interesting aspects of our testing that aren't necessarily the OWASP top 10 perhaps. So with that, let's start with you can't really argue with this, but Portswigger has put out some awesome research over the years. You can't deny that they're one of the leaders in research, and one of the interesting things that came out with them that was presented at Black Hat USA 2023 and DEF CON 31. James Kettle did a presentation called "Smashing the State Machine: A True Potential of Web Race Conditions," and that's something that really wasn't, I wouldn't say, the forefront of web security testing is race conditions. So we wanted to kind of let's take a look at that and see kind of different aspects of that we've seen in our testing, um, where it could possibly have a security implication or have some undesired functionality or something like that. Um, I will. One of our examples I'll talk about here is social media. We had one that we were looking at, and typically when you go to vote, I've seen certain things that have a contest. Hey, vote for your hometown, favorite business or whatever it is, and they want to make sure that you only vote once or once per day. I've actually seen some of them go as far as you have to put in a credit card to do a temporary charge or whatever to show that you're an actual person. Um, with this case, this was social media, and you could like something, and you were only supposed to be able to do it from your account once. But there was a race condition where, if we use like Turbo Intruder, we could like something many more times than we were supposed to, and it was a race condition between how many requests we could shove in the door and when it's actually recorded, and then it does the check to see if we've actually liked something. So that's one example of what we were able to do with that. Um, uh, uh, One thing that Rob Simon is known for is his hacking of shopping carts. So much that he has a shopping cart nickname. We actually have some stickers and logos and stuff like that we've made. Rob, can you tell us about anything you've done or we've seen, kind of maybe coupon code, shopping carts, things like that?
Yeah, so there's actually a couple. One, going back to the race conditions, was with shipping calculation. So when testing a website that had a checkout functionality, after you added all of your items to the cart and you would go to checkout, usually at that time that's when the shipping would be calculated based on your zip code or based on where you live. That would be added onto the total before you check out and then finalize the payment. That was what I noticed because I was testing some other things with the shopping cart where multiple times of going back and forth, I was kind of getting the same price because I'm testing with the same items, but then I noticed occasionally the price would be different. Like it would be slightly above $50 or it would be like right around $50. And I was trying to figure out what was going on with that. And it turned out what it looked like was happening was depending on just when I clicked, I don't think it was really within my control. It was just every time I would check out, something was going on with the backend server. So I think the backend server was likely making a call to another API that would take the zip code and do some calculation to see what the shipping would be based on where you live. And if that request was taking too long, the server would respond back to the user and it would just have nothing for the shipping calculation. So it would end up zeroing out. So just by noticing that, if a user would just check out, check out, back out multiple times, you'd get lucky maybe every 3, 4 attempts, and then you would get, $0 shipping fee regardless of where you live. So that was one cool one.
Yeah, so some of these actually have business implications, you know. And that's one of the interesting aspects of this. Um, I had as far as business impact, I had one where you ordered, I'll make an example, like auto parts or something. And let's say you order a new engine and you get it installed. You order it, it gets shipped to your local installer, and I didn't know that it was doing a warehouse pick ticket. They would actually ship it and charge the local shop that you'd have install the auto part. So if you didn't like the business, you could actually order a bunch of stuff to there and not pay for it. So it's just interesting aspects depending on what business vertical things are in.
Back to the coupon code you mentioned, that was another interesting one on shopping carts as well. Um, some sites will allow you to say get a coupon when you pay something like $35 or $50 in items. You get something free or you get free shipping. So a specific one that we saw was for free shipping on items over a certain amount, like $35. And a way that we were able to use that was to add $35 or more worth of items into the cart and then apply the coupon code. But then you could go and remove the items from the cart that you did not want and just keep, say, a $5 item. So you just needed enough to get it over the limit, get the coupon code applied. But then after removing, the logic wasn't rechecked. So you could proceed all the way through the checkout and get free shipping on something that was not meant to get free shipping.
Interesting. Didn't we have another one too? Something with a guest cart and not being authenticated.
Yeah, that was a neat one, Scott. I believe the issue there was you could start out with the checkout process, apply some coupons as a guest, and then if you were to log into the site, it migrated your shopping cart to the new session, but it lost track of the fact that you'd maybe already applied some discounts or something, and it was possible to do them again, which I think is a neat example of things that, we do find on app tests that, your security scanner and stuff is never going to find those kinds of logic challenges and stuff like that. It's a really good opportunity, a real high value that comes out of these types of tests for clients.
All right, awesome. Anything else to add in kind of race conditions or kind of shopping carts there before we move on? All right, we have one from a question here. Curious how we're going to approach dealing with the CISA mandate for Executive Order 14028, and that's the nation's cybersecurity executive order. I think, Geoff, you probably have the best response there.
Yeah, I think the answer for us right now is going to be kind of a lot of keep on keeping on with what we're doing as far as that. I definitely foresee us, updating some of our verbiage and stuff to, comply with what the order requires and to make sure our various agreements, as far as NDAs and stuff, allow us to participate as required by that. However, we're still waiting for a lot of the specific details as far as how some of that's going to work, and we're just going to kind of adapt as it happens. Certainly, we're going to be there to help our clients do the tests that are required and enhance their security posture.
All right, awesome. All right, moving on. Another question we frequently get from clients. We get a lot of interesting questions. Each business has their own unique challenges, and one of the common things we get is how do we test? How do we get the most value out of our test? And one of those things that comes up is we have a WAF. Do you want to test our WAF? And my answer typically to that is no, I don't want to test your WAF as our primary source of effort for our test. would prefer to be allow listed during that. So we do the test. We're actually testing the code for vulnerabilities that are in it, and we're not focusing our whole effort on a single security control that's sitting in front of it. So what we typically do is we'll do our test, allow list or ask to be allowed listed, do our whole test, and then at the end of it, we'll take all of our findings and try and reproduce our findings when we are not allow listed to see what your WAF may or may not do. With that being said, we always like to say, hey, this is a single security control in your whole defense in depth approach. And clients say, hey, well, how often do you get around stuff? And the answer is quite a lot. We had an interesting case that we thought would be interesting to bring up here. Geoff, if you could describe that kind of for us. This one has to do with some illegal hex and URL encoding for a WAF bypass.
Oh, yes, this was a really neat one a team member found fairly recently. Essentially, what it boiled down to was the WAF was processing ASCII hex encoded characters correctly, but the application didn't. We ended up speculating a little bit on the backside that the application was probably assembling decimal or binary values out of the hex values coming in without really paying attention to place value. So essentially what you could do is you could take a value, like 0A, which, ordinarily would be, 10 in decimal, and, replace that with, say, G, and actually get the application to see the value 16. That allowed them to start encoding payloads, in ASCII or in UTF-8 of, scripting payloads and things of that nature. And the WAF didn't see it because the consultant was going ahead and encoding those using illegal ASCII hex values that happened to then wrap around to the letter they wanted. So they would put, more than the allowed value in the ones column and let it roll over into the tens column and stuff like that as you reassemble the value in the web app. So the WAF, of course, then doesn't recognize the input even as encoded values. It just sees it as a string of odd-looking characters and ignores it. But yet the application was treating those things as text strings and ultimately enabling cross-site scripting that the WAF ordinarily would have caught and blocked.
We do have interesting behavior like that quite often. We do collaborate as a team often as well, and some of the interesting characters that we've been able to well, this is kind of an overflow case, if you will, but some of the full wide characters, some of the different things that are just accepted or they're replaced, and we've had some luck with cross-site scripting. That's another interesting aspect. I know that less than characters, dash, I don't know what other characters we can think of. I think there was a period, we were doing some chorus stuff lately we were trying to use, but some of the characters that we throw at WAFs and apps in general, sometimes they're just accepted even though they're not really what they are. It all depends on how the receiving software handles those.
Yeah, absolutely. I mean, WAFs are really, really good at defeating web scanners. They're not necessarily as effective when it comes to trying to defeat a human being who's designing a particular attack for a particular endpoint. I think you see that a lot with these attacks, especially if we have reason to believe there is an exploit behind it. There have been a lot of cases where it's like, okay, we know there's a CVE published for this thing. Now it's just a matter of evading the WAF. And you take that proof of concept and you just sort of keep adapting it until it works. And that's really hard to defend against because I think it's one of the oldest problems in information security in a way is trying to enumerate badness. You just can't.
Speaking of old, I've been in the in IT for since the 90s. Show my age a little there. Some of the older vulnerabilities we had were like buffer overflows and things like that. And one of the questions I sometimes get is, do you still see some of those things in a lot of the frameworks, underlying frameworks and languages and things by design handle some of that for you? But an interesting overflow we had, just like kind of the hex overflow in the case he's spoke of there. We had another one that was interesting where we actually had an integer overflow. And back to the shopping cart deal, um, this one, there's a finite number for integer in this case, and we were able to add so many things to a cart that it actually overflowed, and the price reset, I believe, is what happened. We had Whitney Phillips, which is actually on this, is the one that found it. But that was an interesting case of kind of old school and the new school, you know. But that was something that I haven't seen in my career, and I've been doing this for 17 years now.
Yeah, I usually try to look for that too, and I don't always have good luck. I found it on a website where it looked like it might be possible, but instead of using like, 32-bit integers, they were probably using something larger or floats, so it was just impossible to add any amount that was going to even get close to overflowing based on how high the numbers were going. But on the one Whitney found that was pretty cool, she was able to add enough stuff to the cart to where what happened was it overflowed back to a negative value, but then she needed to check out and wasn't able to check out with that negative value. So she needed a way to try to get it at least positive. So the idea there was, overflow it. You got a lot of items in the cart, and now you want to check out and get them out for free. But so we still need to get it like over the finish line there. And she found that in this particular app, because it was like a food service thing, she was able to add a tip that was enough to just get it back up to like slightly over zero, which was just enough to actually check out with a positive value. So it did have some kind of logic that prevented you from checking out with that negative value, but once you got it over positive, now you still got all the stuff in the cart, and then the amount has now rolled over past negative and then back to positive again.
Yeah, I mean, when I do training and just kind of security awareness presentations, one of the things I like to call out is what I like to call the hacker mindset, kind of thinking outside the box, as most people would call it. With that being said, with most testing that TrustedSec does, we often offer a complimentary retest for some findings by default. And with that, some of the interesting things that we find are ways to bypass fixes that clients have done. One of the common ones that I can think of is there would be an unsafe or an arbitrary origin trusted for cores. And what they're doing is they're simply looking to match, companydomain.com. And then what we do is companydomain.com.trustedsec.com. So we actually own that, but they're doing a contains match, not an ends with. So that's a common, you tried to fix it, but we still bypassed it. So with that being said, Geoff, we had an interesting one kind of with some regular expressions. This one was actually, I believe, command injection.
Yeah, so this was a neat one, and I think it also really highlights the value of doing the source code assisted assessments with us. This is an app that we had tested a number of times, I believe, and you know, there had been this path variable that I think we had always kind of looked at and made notes of, to the effect of this looks really kind of suspect, but we never were able to do anything with it. And then we did a source assisted test and actually were able to find that code as the consultant was going through it. And Luke, genius that he is, noticed something fishy with the regex. He saw that it was actually looking to match an inline character, or rather a start line character, I believe, that shouldn't necessarily needed to be there as far as blocking the inputs. So what he did is he actually led his payload with, I believe, an inline. Could be mistaken with the specific details, but he found a way that he was able to actually evade that regex and enter a full path. And so the attempt to make sure that that was a local file failed, and actually that resulted in him getting a path traversal out of that, which in the context of this application was a pretty significant risk.
Yeah, I mean, command execution, I don't know if it was authenticated or not, but I mean, that's, about as bad as it gets in many people's minds. That's the, oh my gosh, I got RC. That's the crown jewels usually from an exploit side of the house. All right. Another interesting trend or request we've been getting from clients in the last few years that is new or at least more popular let's say, is us testing kind of thick client desktop apps. There's been more of a request or focus on that. I don't know if it's just people, doing their due diligence, more focused on security than there was years ago. But desktop applications rather than traditional web applications have been a focus. We've done everything from a desktop install in most OSs to click once installs to Java applets to you name it. We've probably worked with it. An interesting part of this is a lot of people might not know that OWASP actually has a top 10 for desktop application security risks. And some of those are similar to the OWASP top 10, or let's say years ago. And I'll just kind of read through those. It's interesting. Some of the same things that we have in the web applications are also mirrored in the desktop applications. So DA1, injections, SQL injection, LDAP, XML, OS command injection, things like that. I would say there's no surprise there. That's part of talking to the back end API or whatever it is it's connecting to. Broken authentication and session management is number 2. Same stuff as a web application. We have the same kind of stuff. Sensitive data exposure. This one's a little different because we have data in memory, we have local files. Other interesting aspects that we look at are permissions of installed applications, whether they're just standalone, if they're actually installed, how they handle cryptographic secrets, things like that. One of the aspects of that is also file system permissions. What type of rights are needed to run something like that? Things, if there's any services, unquoted service paths, etc. Improper cryptography usage is number 4. Improper authorizations, number 5. 6 is security misconfiguration. 7 is insecure communication. And these are all things that could be in web applications for the most part. And then we come down to number 8, poor code quality. So it's saying missing code signing and verification for file integrity, code obfuscation, DLL preloading or injection, race conditions, lack of binary protection, etc. So some of those would be more closely aligned in the mobile world. Speaking of mobile, we will have a mobile AMA coming up later this year. So we'll Rob and his team members will cover that later this year. So we're going to kind of bypass some of those today.
Scott, you mentioned desktop applications, and I think, obviously everybody's always loved desktop applications and thick clients because, it is a richer experience often than the web, even now. I think one of the things behind the renaissance of those to some extent has been, web services rather than doing a custom RPC for everything. You can back that fat client with the REST API, and consequently, that has created a lot of opportunity for us to do API testing, of course, because people are implementing those technologies in REST. And that is something TrustedSec offers and can certainly help you with as well. We do pure API tests that don't necessarily have to involve the application. So I said, I think we should point that out. But definitely, looking at both the client and the API is always better coverage. So of course we love to do the full integration test, but especially looking at APIs where we're supporting the mobile application, we're supporting the desktop application and the website with maybe some of the same APIs. Just doing a pure API test approach can also be a quick way to get a lot of coverage and a quick way to get coverage over the actual data endpoints, the things that you probably care about the most.
Some of the ones that I've tested for clients, it's interesting because typically one of the reasons you'd use an API is you can support multiple things, your mobile apps, your website, whatever. Some of the desktop apps I've touched, they reach out, but they're not known anywhere else on the public internet. Nothing else uses them for whatever reason. And they typically, well, I don't want to say typically, but in many cases have lacked traditional security controls. I've seen things, full database queries being passed back and forth, or other aspects of it. They'll encrypt everything that goes back and forth. And I'm not talking about TLS. I'm talking about they take each parameter and the user ID equals 12 and they encrypt it. So it's just some base 64 something. And then we'll reverse the desktop application and find the encryption keys embedded in there and simply write a little console app to encode, decode, or through burp or whatever it might be. But that's another aspect. A lot of hard coded things. Um, we had one of the attendees ask. They have a lot of engineering desktop applications that act like, say, high-end calculators and stuff, but they don't connect to external services, databases, APIs. It's kind of a standalone thing. It looks like. What are some threats to test for when you're dealing with those simple desktop applications that lacks, let's say, a session context, external connections, path traversals, whatever? What will we look at to, something to allow a user to get access to their own file system or something?
Sure. That's one of those things where it's going to probably be a lower priority than some of your other apps, but it still may absolutely be worth looking at. Some immediate things that come to my mind are, can the application be used in an abusive way? And that would be if that application is able to load any files or anything like that, as an attacker, would I be able to produce a file that triggers an overflow or something like that in that application and then induce a user potentially to open it? So if you've got any kind of save load feature, if there's any kind of serialization going on there, that might be a concern. That's definitely something we would test for. Simply using it as a way to phish people and take advantage of trust in your organization. Can I distribute my own copy of that application that I've modified in some way with a Trojan or something like that? So some things like that is, did you put a digital signature on it so that users can actually verify it is from you and a trusted source? Um, those are some things off the top of my head immediately, that I would look for and test for in that. Rob, do you have some other ideas there?
Yeah, the serialization, that's definitely a good one if you're not familiar with that, but that's basically a way that, like Geoff said, if you open a file, that might actually cause code execution. So it might seem benign to open something, but um, you're basically somebody else is attacking you. It's not so much you attacking yourself is what you have to worry about that. Other things, it really just kind of depends on the context of the application and what it does. You might not have, say, a session or a login to the application, but if it's an internal type application, maybe it has some hard-coded paths to internal sensitive directories, or maybe even credentials to those directories or into a database or something like that, that you might not necessarily directly have access to. So maybe you open it up with no login, and you're able to run some calculations and it gets stored off somewhere. But if somebody takes it apart, they have those credentials to some kind of sensitive database or file share, and now they can get in there and tamper with the files or pull down files that maybe only select people should have had access to. And other things, this is kind of straying a little bit more from, say, the specific example of an engineering desktop application, but we've also looked at applications that don't necessarily have or deal with a lot of sensitive data, but maybe they were made more for end consumers. This is a product that's going to be sold and it has licensing in it. So that's another area that we have taken a look at for desktop applications, where the threat is more specifically somebody stealing the application or bypassing the licensing controls. So taking a look at that to see how robust are the licensing controls? Are they very easy to bypass, or is it something that would take some effort? Usually we would also assume that given enough time, an attacker may get around that, but the way we kind of treat those is looking at it from a perspective of how much effort is it going to take? So, is this good enough based on the audience you're trying to sell to and how popular the application is going to be, or is it pretty trivial to bypass kind of thing?
Some other things to think about too, and these are all stuff that we commonly look at whenever we get asked to test a desktop application. The actual installation of that. I mean, if it's a zero install or something, there isn't so much to do there. But if it is an application that you can install for multiple users and stuff, does the installer set directory permissions correctly? Does it set registry key permissions correctly? Anything that would actually lower the security posture of the host itself. I've seen installers that you have to be administrator to install it. So of course it has permissions to make file system changes. It's actually altered the permission on the program's file directory improperly. And so that could lead, if that is a multi-user system, that can lower the security profile of that entire host. So there's stuff like that is absolutely worth looking at. And sometimes it's great just to have a third party, look over your shoulder and make sure those things are right.
I help with our red team and some of the other external pen tests and stuff a decent amount. And one of the things that I do if I encounter it on the public internet, some sort of install or desktop application, is one of the things. Can I decompile it? I look at code comments. Are there any usernames, developer usernames that might clearly clue me into a format, just like we would look at metadata on PDFs or Office files on the public internet for an author in the metadata. Another thing I like to do is run strings on it because that will give me a list of potential strings that I could then use for password cracking or brute forcing. Just different little bits of information that we can gather from those, even though it might not be have any connectivity. That's the level of effort we go to on the red teams and such when we're doing a focused effort. Alrighty, so we got down to number 9, or nope, that was number 8. Poor code quality. That was missing code obfuscation and such. A lot of these, some of these mirrored over into the mobile application side of it. Things that you guys check for on that. Number 9 was using components with known vulnerabilities. We see this all the time with JavaScript libraries on our web applications, obsolete or outdated and such. And then number 10, insufficient logging and monitoring. So that's kind of a monitoring detection side of things, but that's what they have for the OWASP desktop top 10. So they have a pretty good list there. A lot of those cross over, but some of them are very unique. Definitely the file system permissions and some of the more local pieces. While we're in kind of desktop mode here, another interesting aspect of things that we test is also kiosks, or what we like to call controlled environments. So think, I'll just use a vendor, Citrix. You can publish a specific application versus just a whole desktop. So if you're not familiar with how it works, you can publish a full desktop to someone that's like remote desktop, login, VDI, whatever. And you can also publish an application, but that application actually pops up, looks like it's running in a window on your computer, but it's actually kind of, think of it running remotely on the server, in a context on the server and everything like that. But instead of being displayed the whole desktop, you just get that application. So one of the interesting aspects of those desktop applications that might be homegrown or whatnot published through some sort of VDI, we look for escapes in those. And really we look for, if you're trying to get into Windows or out of Windows, think you're at the mall and there's a kiosk for photos or whatever it is. What can you do to get to the operating system? And let's assume it's running Windows. So any functionality that we can get to break out of that. So think about Windows Explorer, or Internet Explorer, Edge, whatever they call it now. You can tell I don't use it that much, but anything that has operating system functionality that you can browse the file system will allow us to get out. So a print functionality. Are there any links that's in the exposed application, like say even a copyright or a terms and conditions? There's a hyperlink, I can click on that and it opens in the default browser. Even though they might have only published this one application, boom, it's going to open up the default browser. Next thing you know, now I have a web browser in the security context of the remote server. So print functionality, file uploading, anything that would pop a file browser, and it's actually going to pop that on the server side, not on your local computer. So that's an interesting aspect in that scenario of how things are published. Do you guys have anything to add to kind of the what we call our controlled environment testing?
Yeah, I mean, we see that a lot, not just in like Citrix type stuff, but you did mention like kiosk type environments. So you could think, like you said, things that you would walk up into a store. You know, we've tested things like that, ATMs or anything like that. But definitely, it's a lot of, you know, clicking around and basically just finding a way that you know, maybe you didn't intend to be there or thought would be helpful to get to some kind of window that will allow you to browse that file system is usually the starting point. We've seen ones where even with browsers, they can be locked down usually pretty well, but just very simple one that I looked at recently. I tried a whole bunch of stuff. I didn't even realize that what I was looking at was a browser window because the page looked kind of like a desktop application almost. But literally just hitting Control T for that new tab, gave me a new tab that had the actual uh, bar where I could, start typing. So, you could type file : / and then from there, now you can start browsing the operating system, which doesn't sound like it might be too big of a deal at first, especially if you don't have sensitive information. But if you're trying to keep someone off of the operating system, there are some kind of convoluted paths we can take to eventually get something where we can get more of like a shell access or something to that from there. So, the very simple basic examples that we've seen before is just, browsing to command.exe and opening it, or right clicking and opening. But there's other paths that we can take, to get there as well.
I've seen somewhere they have cmd.exe and you can't open it, but you could make a copy of it and then open it, or you could rename it to something else other than cmd.exe and then it would work. You mentioning the file protocol handler there, file : / whatever. I had an interesting one where I was trying to do some data exfiltration, and they had a list of sites that you couldn't go to, and there was only one or two that you could go to. And I'm trying to exfil data, and what was interesting is I could write to the local file system, and I made just a little iframe window, something or other. And what it did is it was intercepting, this desktop app was intercepting copy and paste, but it would allow anything to the local file system. So basically what I did is I used the file protocol handler trick, opened it up in this browser where I was trying to exfil the data from, paste it in the local file, and then I could be off and running from there. And that's how I got around the clipboard restrictions. So that was an interesting one as well.
So cool thing is, Drew was even helping me on this one that I was looking at, where he tried to whip up a cool page where I could browse to that on a different system from that browser, which should give me the ability to write to the file system, so I could create things and save them to the file system. But unfortunately, the system we were looking at was pretty locked down with firewall rules, no outbound access, could only access, the local host itself, or the file : / and browse. So that was kind of out of the question. But this was just a really fun one where we were able to find, this was a Linux-based system. It had a private key that could be saved, or a private key that could be viewed, if I get this right. But we had no way to get that off. So I took a picture of that, and Drew thankfully went through the picture and typed every character of this key out for me, this SSH key, and then found the other part of the key. And just due to the way that it was working in the browser, when you click it, it would try to automatically download the file, so you couldn't view the contents. It would just try to save it again to the file system. It would automatically go into a specific directory. So one of our other consultants had a really genius idea, which was we could go into the browser settings and then configure it to prompt us where to save the file and what to name it. And we were able to save that to the the known hosts, so that key would be allowed. So basically it's the same format, it's just the only key is going to be the key file that we saved. And then using the other half of the key that Drew meticulously typed out and tested multiple times, we were able to finally SSH into that machine by doing that. So just from file browsing and happening to have kind of the right set of circumstances, allowed us to get into that.
Yeah, I think that's really a lot of these kind of supply chain attacks and just attacks in general. People are wondering, well, how do they get in? I think the attackers are really getting creative on some of these things. Back in the day, it was easy. You just, here, do your SQL injection. It's got excessive permissions. Boom, you're off and running. And a lot of things today, that you've got to work a little harder, be a little more creative. So with that, things have changed a little bit. And Geoff, we have a question from one of the attendees. What are the most common findings that we're seeing in engagements today?
Yeah, I'd say there's kind of two classes of findings. There's the stuff that you probably already knew about or reasonably could have found out about, your security headers and stuff like that, which of course will report. A lot of that stuff, every web app has them. Essentially, if you haven't deployed that application within the last 8 months to a year or so, chances are, we've gone to a newer content security policy version. We're up to 3.0 now. So you may not be using all the latest and greatest flags and stuff there as far as enabling the strongest client-side security settings. So of course those things show up, and those things show up on almost every test we do. If you get that on a report, you should feel good. That's maybe the more exciting thing that you're seeing. But in terms of real vulnerabilities that actually have some, I would say, immediate impact, the two things that I say we still see the most of are either direct object references of some kind or another and enumeration attacks. Certainly your direct object references, the old school example of, take the database ID, go from 1701 to 1702, and you're looking at somebody else's record. That still happens fairly often. We see a lot of applications that have moved to doing things like using GUIDs and stuff like that. They make some weak assumptions about how secret those things are. And there's really two things that often come up with that. A lot of people have not thought about the temporal implications of using a unique identifier as the security mechanism, which is to say, if I am a user and I was authorized at one point, I get that identifier, I go access that document or that resource that's tied to that identifier. And I save that identifier somewhere, or it's saved in my browser history or something like that. Long after you remove access from me, maybe I can no longer query the service that gives me the list of identifiers, but I have the identifier, so I can go and still find that file, even in that S3 bucket with no things listed, and I can get the latest version there. So that one comes up a lot. And the other variant, of course, on that is, we have multiple services that are passing unique identifiers around. There are certain assumptions that, one resource is supposed to get you the identifiers that you're supposed to be able to use to access the other resource. Later, we kind of continue expanding our application. We forget exactly, how that security model was supposed to work as developers, or maybe we were just new to the project and we didn't ask or never understood in the first place. We create another resource that provides some sort of enumeration feature, and again lets me start discovering identifiers. There's some blogs out on TrustedSec's website on this topic if you want to explore it further, but where we have some more concrete examples. However, the idea is you discover those identifiers, and suddenly you're now able to access those resources. And then of course that gets you into your more general enumeration type vulnerabilities, which we still see a lot of. And the impact of those can be different. It can be a precursor to a credential stuffing attack. It can be a more serious enumeration risk. A good example is things like gift cards. Can I look up and find out if a gift card number is valid by the fact that the check balance feature works or doesn't? Maybe we're making an assumption that you need the gift card number and a PIN, and you're not going to be able to figure out those two things. Well, what happens if the attacker goes to the grocery store, grabs that stack of gift cards off the rack there, photographs the back of them, waits about a week, and then starts to try brute forcing PINs just against those cards? If that PIN is only a handful of digits, say 4 or 6, it may now be possible to start doing some discoveries against those known valid numbers. And once those cards actually get activated and some money gets loaded onto them, now he has the number and the PIN, and our attacker is able to drain that card and take advantage of the person who bought that. So there's some of those types of things that usually there's some moving parts involved, but those are a lot of the types of vulnerabilities we see in apps.
All right. Thanks for that, Geoff. We had another question roll in. If we have any cool findings where we've chained multiple attacks together, I would say absolutely. Rob, I think you've got one you can talk about.
Yeah, so I don't know if this one will necessarily be considered chaining together, but it was kind of neat, and I thought it might fit, so to talk about it. But one, I haven't seen it in a while, but one that I really liked that I always thought was a cool one for me personally was the XXE type attacks, and then just kind of what you can do with those. If you're not familiar with those, it's XML external entity processing. So applications that deal with XML files or parse those. There is an entity tag in there that you can kind of mess with and get certain things to happen. One of the interesting things is being able to say pick a file on the file system, and then that gets referenced like an external XML file that gets pulled into a variable that could be, depending on how the XML is processed, that variable could be referenced within that XML document later. And if the application processes that and is vulnerable, it would pull the contents of the file in and then display it on the page. What I think that is kind of cool about this, and I'm kind of considering chaining together, is using that for port scanning internal systems through that system. So maybe things that you wouldn't necessarily have access to on the internal network, maybe other internal, maybe you're hitting an external facing web application, but there are internal applications or other applications there that might be visible over the network. It is possible to kind of port scan systems and see what's there. And if it's a web content on 80 or 443, the really cool thing is you can kind of pull the HTML back for those pages sometimes, and then get that to render back on the page. So you can sometimes see other internal applications pivoting through that a little bit. It is a little bit limited. It's say kind of hard to try to use that to go further into like maybe logging into the application, but it's just kind of a cool way to start peeking around inside of the network through that vulnerability.
Awesome. I'll go through kind of one that I had. I've had different variations of this over the years, but I'll just call this one a worst case scenario because our end, kind of what we landed on, was two different methods of command execution from the public internet. Basically, we brute forced logins. I still do it to this day. I have what's called our service accounts list. So think about things that would run as a service in a network, SQL accounts, whatever it might be, or your demo, guest, test, training, stuff like that. Your real basic weak passwords. Yes, this stuff still does exist. That's why we still use it. So we broke into this application with this case. There was a file upload. We did a file upload. It allowed some sort of, it didn't restrict file types. I think it did, Rob. I think you helped on this one. And we uploaded a web shell, a classic ESP or something, and it was filtering it out, but it was case sensitive. So I think so we got a file upload that way, and it was running. So in that case, the commands you'd execute would be in the context of the web server. In this case, it was running with excessive permissions. So not only did we have multiple failures on weak passwords, file uploads, excessive permissions, that was kind of one path where we ended. And then we also had another aspect where it was SQL injection. We got in there. It was error-based. We could dump the data. It was running with excessive permissions. We could see other databases for other applications. The data was there, unencrypted, at rest, etc. So it was Microsoft SQL Server. We got command execution there with XP command shell. In that case, we're actually executing as a SQL Server service on the database itself, which was a different server than the web application server. So we actually had command execution on the application server as the web server itself, and then also on the SQL server over there. It had excessive permissions. From there, egress filtering out to the public internet. We chained everything together. Everything we touched pretty much was worst case scenario for this, unfortunately. They also had central authentication where multiple applications used all those credentials. So basically, once we got the credentials out of the database that were plain text, we got into everything. So it kind of flows downhill from the web shell. Also look at database connection strings that were plain text. It's kind of, there were multiple findings, but one thing led to another until ultimately we were inside. So Geoff, you had one that you wanted to talk about.
Yeah, I mean, it's not uncommon at all to chain vulnerabilities together in web applications. A recent one that I can think of, there was an application. It had a reporting engine on it that had some issues, shall we say. Once we were able to locate the reporting engine, we found a path traversal vulnerability that let me control which report it would read. It was actually possible to do remote file inclusion with that. So at that point, I was able to write my own report document and have the server render it, which was neat, but not terribly immediately exploitable. tried to do the usual things with that, of course. Can we coerce authentication by having it, go to a UNC path and stuff like that? Didn't really get anywhere. Found out that it was possible with some additional flags on the reporting engine at that point, going and just kind of reading the documentation for it, so to speak. Always got to read the manual, right? You could cause it to write out a file, and there's different types of report files it could generate, and one of them was HTML instead of a PDF. So I thought, well, that's interesting. So I actually found out it was possible to get it to not write its temp directory, but to write another file as well. So there's now two path traversals. I could get it to load my remote report file of my choosing, and then I could have it write out a file locally on the file system with that chosen content, at least if I went through the process of having this report file write out a web page. So of course, I was able to write myself out a web shell and write it into the applications directory and actually gain access there. So we went from two file inclusions to a directory or a file overwrite, and finally command execution there. So those are kind of fun, especially on web tests, to be able to throw proofs of concepts together like that. Um, it just depends on the client, and that's something we're going to talk to you guys about whenever you do an engagement with us, as far as, well, how far do you want us to go? Do you just want the list of vulnerabilities, or do you want us to try to get in and escalate privileges and actually control the host? Those are all rules of engagement we can talk through, of course, but when sometimes there's a good opportunity there to show some impact and get the buy-in internally within organizations to start fixing things and taking some of the stuff seriously, in a way that just a list of web vulnerabilities doesn't always get. So we enjoy the opportunity to do those when they come along.
All right, awesome. Rob, did you have any more, or that was it for the chaining vulnerabilities together? I mean, we do it a lot. Just some of the more impactful or interesting ones, I guess.
Yeah, I think I'm good on that subject if you want to move on.
Okay. We had a question. Can we go over some of the best bang for your buck mitigation techniques or strategies security teams can focus on both web and desktop apps? This is an interesting topic that we help clients with. I'll point to a blog that I wrote way back in 2015. It's on the TrustedSec site. I apologize for the formatting on it. The formatting didn't come over when we did our new site, but it's called Web Application Security in a Large Organization, Knowing What You Don't Know. And I think Alex Hammerstone is a big proponent of knowing where your data is, and that's what he talks about a lot. And I agree with them wholeheartedly here. And this blog basically talks about my firsthand experiences when I worked at a Fortune 1000 organization and some of the things I was tasked with doing or did. And number one, if you don't have an application catalog, you don't know what applications you actually have. It's going to be a challenge to secure them if you don't even know you have them. Kind of the software bill of materials, the SBOM that people are doing or talking about, knowing about that. Also, knowing what third-party dependencies there are within those. What frameworks do they use? What JavaScript libraries? There are products out there. There are vendors that have products that will scan code and say, hey, this is a third-party library, and compare licensing and things like that. But knowing what you don't know is half the battle. So like if you happen to watch the TrustedSec's YouTube channel, Carlos has a weekly thing where he talks about the vulnerabilities that came out. So I just watched that yesterday, and there's one with CGI and PHP. Well, if you don't know you have PHP or that it's used, it's difficult to tell. So knowing is half the battle. Once you have that, knowing who the business owner is and what type of data there is, tying that, say, to your data classification policy, would also help, so you understand right away what's the impact to some of these things. As far as the best bang for your buck, in my opinion, every little bit helps. So your organization, I don't really. Whether or not you don't always need big budget, whether or not you have subject matter experts or kind of full-time resources to spend on these things, but there are free static source code analysis tools, dynamic tools, but every little bit that you integrate helps. But I guess anyone else have anything else to add there? I mean, really, the biggest thing for me is knowing what you have. Um, Depending on languages, desktops, this, that, there's a little bit of everything. Do your dynamic scanning, your static scanning. Um, each organization has its own unique challenges.
I would say
Yeah, I mean, oh,
one
sorry, go
last
ahead.
would add to that. Sorry, Rob. I'll give you a chance here in a moment. Scott mentions, knowing what you have and also in addition to maybe knowing exactly which frameworks and stuff are in use, if you've got an application and it's written against a current framework, an older version of .NET, an older version of Rails, something like that, um, you know, migrating that application to the current version. And I don't just mean, installing the compatibility libraries and, getting it to run again. I mean, actually, doing that uplift. Usually there's a lot of gain there in terms of improving the security posture of that application. Go ahead, Rob.
Sorry, I was just gonna say, yeah, making use of the frameworks too, though, like you were talking about, but just making use of the frameworks rather than kind of rolling your own on stuff too. We see that occasionally as well, and trying to re-implement input encoding or input sanitization and output encoding and things like that. You're possibly going to miss things. Not that it can't be done. It's just, if that's provided for you, that library is going to be updated. It's probably going to have more robust testing and stuff done against it. So starting from that, and looking at what are all the features provided to you by the language or frameworks that you're using for security features and trying to make use of those or understand those before
Having
kind of rolling your own.
having a formalized process goes a long way, and having security embedded in there from the requirements elicitation stage at the very beginning, and having someone with a security mindset from the beginning. It's way cheaper to develop secure software from the beginning than fix vulnerabilities afterwards. So having that mindset or someone with that input at the beginning is huge as well.
And if you're doing unit testing as well, it might be good to add unit tests for certain things, especially once they've came up in a security test. That may be something you didn't think about, like the integer overflow stuff. If that's something that you can wrap up in a unit test to try testing that, out with multiple negative values and things, just to make sure that that doesn't happen again. As you're changing code, that doesn't get reintroduced later or in a different area.
Yep. Alrighty, well, that's all the time we have for today, folks. We definitely appreciate you joining. Like I said, we'll have a mobile MA later this year. There might be IoT mentioned in that. We'll leave that up to Rob, but I want to thank everyone for joining today.